I'll be taking up a new topic, analytic geometry, in this video. These are roughly the subtopics that I plan to discuss under analytic geometry: the plane, the straight line, shortest distance, skew lines, sphere, cylinder, cone, and central conicoids. So it's a fairly large topic, and I plan to do as much problems from each subtopics. So to solve the problems under analytic geometry, I'll be using some basic concepts from two-dimensional geometry and some vectors, some basic concepts from vectors also. So in case if you have any doubt while discussing any problems, feel free to comment under the video. I'll try to address it. So before taking up the questions from the plane, in this video, I will be discussing some basic concepts and formulas. So, and from the next video onwards, we will start solving some questions from the plane. So we'll take up the basic concepts. The first one is a distance formula. So in analytic geometry, we are handling three-dimensional objects and figures. So we have 3 points. So to locate a point, when we are using x, y, z coordinates, to locate a point in a space, we have three coordinates points: x, y, and z. So we have 2 points here: x1, y1, z1, and x2, y2, z2. The distance between these 2 points can be easily found out using this formula. Similarly, we have a division of a line. We have 2 points: x1, y1, z1, and x2, y2, z2, and we have a division in the ratio m1 is to m2, and the dividing point will say, let it be x, y, z. So the coordinates each x, y, z can be found out using this formula: m1 into x2 plus m2 into x1 by m1 plus f2 gives x. Similarly, y is given by m1 into y2 plus m2 into y1 by m1 plus m2. Similarly, z is given by m1 into z2 plus m2 into z1 by m1 plus m2. You should, in the question, if it says divides internally, m1, m2 should be taken as a positive figure. And if it says it divides externally, m1, m2 should be taken as a negative figure. So by externally, it means like, let this be A and this be B. This is the point of division, and this will be m1, and this is the, since this is the point of division, sorry, my mistake, there will be like this m1, m2. So this is the point of division, and it is now dividing. This AB is divided externally. This is the case where division happens externally. To solve such questions, we just take m1 by m2 as negative. That is, say we are given the line gets divided externally in the ratio 4:3. If it is given like this, we will take m1 as 4 and m2 as -3. So so we will apply this 4 and -3 in this formula, and we will get the coordinates of the division. So instead of m1 x2 plus m2 x1, we'll get m1 x2 minus m2 x1 by m1 minus m2, where m2 is a negative value. So this becomes m1 x2. So say 4x2 minus 3x1 by 4 minus 3, just like that. So that is the equation for division of a line. And using this concept, we have two more formulas: centroid of a triangle and centroid of a tetrahedron. We'll be using the formula we just discussed, this formula, and apply the concept of centroid to find out the coordinates of a centroid of a triangle and tetrahedron. And so the concept is, from this one point we draw to the middle point of the opposite side, and so D point splits this line segment into 1:1 ratio in 1:1 ratio, and centroid is nothing but the point that divides this line segment into 2:1 ratio. So G is the centroid, and this line gets divided in 2:1 ratio, and this line gets divided in 1:1 ratio. So we can find out D simply using this formula, which is x2 plus x3 by 2, y2 plus y3 by 2, z2 plus z3 by 2. So once we find out D, now we'll apply this formula again in this line segment. So it is getting divided by 2:1 ratio. And once we apply, we get the coordinate of G as x1 plus x2 plus x3 by 3, and y1 plus y2 plus y3 by 3, and z1 plus z2 plus z3 by 3. Similarly, tetrahedron is a three-dimensional figure. So we have 4 points to define as a tetrahedron. Let that be x1, x2, x1, y1, z1, x2, y2, z2, x3, y3, z3, and x4, y4, z4. Now, to find out the tetrahedron of a centroid of a tetrahedron, we just find the centroid of the base triangle, and let's name it G dash. Now from the other point, we draw a line to the centroid G dash, and this line again gets divided into 2:1 ratio, and that point is the centroid of the tetrahedron, which is D. So this line gets divided into 2:1. So when we apply all the formulas, we get the coordinates as x1 plus x2 plus x3 plus x4 by 4, y1 plus y2 plus y3 plus y4 by 4, z1 plus z2 plus z3 plus z4 by 4. So these are the 4 basic things: distance between 2 points, division of a line, centroid of a triangle, and centroid of a tetrahedron. Now we'll see the other formulas. Next we have spherical coordinates. So earlier we were using xyz coordinates, Cartesian coordinates, where to locate a point in space we use x, y, z as parameters. In spherical coordinates, instead we use r, psi, and theta as parameters to locate a point in space. So if you see this figure, we have r as the distance the point is from origin. So we have r as the parameter, the distance any point is from the origin. And now psi is, if you draw a perpendicular to the xy plane, and we'll get ON, and this angle, that is the angle ON makes with positive x-axis, is taken as psi. So this is the psi, and theta is nothing but the angle this line segment OP makes with z-axis. So that is theta. So we have these 3 parameters, and with these 3 parameters we can locate any point in space. So to find x, y, z from using these parameters, from this figure itself we can find out x is nothing but, if you draw a perpendicular and it hits the xy plane at n, then ON, and we have psi as this angle, so x is nothing but ON cos psi. Similarly, y is nothing but ON sin psi. So we have ON cos psi and ON sin psi as x and y. Now what is ON? ON is this, right? This is parallel. So this line and this line is parallel. So this is nothing but ON. So we have this as R and this as theta. So we have ON as R sin theta. Similarly, z axis is nothing but R cos theta. So we have this x is ON cos psi. That means we found out ON as R sin theta. So R sin theta cos psi. Similarly, y is R sin theta sin psi, and z is R cos theta. So in this manner we can use these parameters to find x, y, z of any point if we want. In some questions can be easily solved using spherical coordinates. That is why we need to learn spherical coordinates. Some questions it makes sense to solve using spherical coordinates. It will be very simple if we use that concept. We will see which all problems uses spherical coordinates in the later videos. So why this name spherical coordinates? So you see this figure. Any point in space, we can imagine it to be a point that is lying on the surface of a sphere, and first parameter is r. So r is the radius of the sphere, and by changing this psi angle, we can move like this in this green line. We can by changing psi, we can locate all the points in this green circle, and by changing theta, we can move like this in this blue line. So by manipulating theta and psi, we can go to all the points in this sphere, right? So similarly, by changing r, we will have a different sphere with different radius, and in that manner, by changing r, theta and psi, we can locate any point in space. Just construct a sphere of radius r that goes through that point, and that will have a particular psi and theta as angle, and in that manner we can locate any point in space using this. So that is why we have this name spherical coordinates. Now few observations are if x, y, z is the point in the space, x square plus y square plus z square gives r square. So that is the relation. And then tan theta, this is theta, and tan theta is nothing but this opposite side by adjacent side. This is r sin theta by r cos theta gives tan theta. So this is nothing but this is x square plus y square on by this is on, right? On is hypotenuse of this triangle, which is x square plus y square. Root of x square plus y square gives on, and by z. Z is this. So I'll just note that down. On is root of x square plus y square, and that is the opposite side, and this is z. Z is equal to r cos theta. So x square plus y square by z gives tan theta, and tan psi is this opposite side by adjacent, which is y by x. So these are some formulas we could use in the problems. Just understand this, how this comes, so we don't have to just mug it up and memorize. So this is spherical coordinates. Next is cylindrical coordinates. So in cylindrical coordinates, we have the parameters as r, psi and z. So let's consider a point P. From this point, so let me just from this point draw a perpendicular to the xy plane, and it meets at this point. So this distance is called r. So the reason is we are just like we constructed a sphere, here we are considering the point to be lying on the surface of a cylinder. So this radius will be r, and once we have changing the theta is the angle it makes with x-axis. So changing once we have an r, we can change theta to cover distance like this, and by changing z we can cover distance like this. So just drawing an example. So by changing r, this theta and z, we can locate any point as a point on the surface of a cylinder. So just this, if you see, any point can be located in the surface of a cylinder like this. So we just need r. R will be the distance it makes. If we draw a perpendicular to the xy plane, that point of intersection and the distance from the origin is r. So r, psi and z, these three are the parameters. And if you see, x is nothing but r cos psi, and y is nothing but r sin psi, and z is given as z itself. So these xy, it can be mapped to xy z like this, and x square plus y square is r square, and tan psi is nothing but, oh, it's not written here, tan psi is opposite side by adjacent side, so y by x. So this is cylindrical coordinates. We will be using in certain problems when it is better to use cylindrical coordinates. We will see which all problems use the cylindrical coordinates. Now we have spherical coordinates and cylindrical coordinates. And next we will see direction cosines, the concept of direction cosines. If alpha, beta, gamma are the angles which a given directed line makes with the positive direction of the axis of x, y and z axis respectively, then cos alpha, cos beta and cos gamma are called the direction cosines, briefly written as DCs of the line. These DCs are usually denoted by L, M and N. So this yellow is the line in discussion, and it makes alpha with the positive x-axis, beta with the positive y-axis and gamma with the positive z-axis. So L is cos alpha, M is cos beta and N is cos gamma. So DCs or direction cosines, when we say, we denote it by L, M and N. Now if you see, Li plus Mj plus Nk is a unit vector in the direction of this line. So let me just write, okay, in this direction. This is the direction, Li plus Mj plus Nk, this same direction. I draw it in parallel, so the same direction. If we construct a unit vector in the same direction, it will be Li plus Mj plus Nk. And since this is a unit vector, if L square plus M square plus N square will be 1. So we can use that in the problems. So once you understand the concept of this direction cosines, we can easily see that if we are asked the DCs of the x-axis and y-axis and z-axis, it will be respectively, since the angle alpha will be 0 in for x-axis. If we take x-axis as our line, alpha will be 0 and beta and gamma will be 90 degree. So cos 0 is 1 and cos beta will be 0 and cos gamma will be 0. So DCs of x-axis will be 1, 0, 0, and similarly for y-axis it will be 0, 1, 0, and for z-axis it will be 0, 0, 1. So this is the concept of directional cosines. Just take a pause and have a look. If you have any doubt, do comment under the video. Next is the concept of direction ratios. If the direction cosines Lmn of a given line be proportional to any three numbers a, b, c respectively, then the numbers a, b, c are called direction ratios, briefly written as dRs of a given line. So this is a simple concept. Lmn is a ratio which has some special properties like L square plus M square plus N square is equal to 1, right? So and L is cos alpha and M is cos beta and N is cos gamma. So if we multiply throughout with some constant numbers, we will get another ratio where L is to M is to N will be same as A is to B is to C. So if you are able to find some ratio like this, where L is to M is to N is same as A is to B is to C, then these are called DRs. Here, as you can see, A square plus B square plus C square need not be 1. So need not be 1. If it is 1, it is nothing but L is to M is to N. Such small, so this will be DCs. So any other ratio which is same as this ratio can be said to be a direction ratios. So to find from direction ratios, we can find this direction cosines by using this formula. L is nothing but A by root of A square plus B square plus C square, and M is nothing but B by root of A square plus B square plus C square, and N is nothing but C by root of A square plus B square plus C. So if you see, L square plus M square plus N square will be A square plus B square plus C square in the numerator, and A square plus B square plus C square in the denominator, and cancels, and it becomes 1. So this is LMN from direction ratios. So this is the concept of direction ratios. The next concept is projection of a point on a given line. We have a given point P and a given line AB. We need to find the projection of this point P on this line AB. So for that, we have to draw a perpendicular PM to AB. So this is perpendicular, and this foot of this perpendicular M is called the projection of point P on line AB. So the steps that we need to follow is, we just need to draw a perpendicular to AB, and that foot of the perpendicular is called the projection of the point on given line. So this can be imagined in a different manner also. We need to construct a plane that pass through P. So this is our point. We need to construct a plane that pass through P, and which has its normal as AB. That is, the plane is perpendicular to the line AB. Now, if you construct such a plane, the intersecting point of the plane and the line AB will be the foot of the perpendicular. So we can imagine the projection of this point on a given line as in this manner also. So remember, all these concepts are discussed in a 3-dimensional geometry. So it is not in 2-dimensional space. So line AB is in three-dimensional space, and point P is any point on a space. So yeah, point M is the point in which plane through P and perpendicular to AB meets the line AB. So this is the concept of projection of a point on the given line. We will be using this concept in the next concept. The next concept is projection of a segment of a line on another line in the same plane or another plane. So what do we have here? We have a small line segment CD and a line AB. If you see the image, we have a small line segment CD and we have a line AB. We need to find the projection of CD on line AB. So we just discussed the concept of projection of a point on a line. So what they are asking is, if find the projection of C on this line AB, so we will get C dash, and find the projection of D on this line AB, we'll get D dash, and C dash D dash is the required projection of this line segment on this line AB. So for this, just like we discussed earlier, we'll construct two planes that are perpendicular to this line AB and passing through D and C respectively. So we'll have two planes. These planes pass through D and perpendicular to AB, and in this plane pass through C and perpendicular to AB. Now, if from this point D, if we draw a perpendicular to this plane, if we draw a perpendicular, you can see this DP will be parallel to AB, or DP and AB have same direction cosines, right? Both this line DP and AB are perpendicular to this plane, so they are parallel and have same DCs. And the angle this DP makes with CD is, let's say, it is theta. So we have this line AB, and we know that we know the direction cosines of AB. So we can easily find out this theta that CD is making with this DP. So C dash D dash is nothing but the length of dp. So which we can easily find out taking CD cos theta. So CD cos theta is C dash D dash. So we just need to find this theta, and if we take CD cos theta, we'll get this line segment. That is this concept. So from the question, let's you just pause a second and read what is written here. It is explaining what I just described. So D dash C dash is nothing but DC cos theta, and in such questions we will have DC, a vector A, and let B be the unit vector along AB. So if you take A dot B, we from question we can find B and vector A. If you take dot product A dot B, what we'll have? Magnitude of A into magnitude of B into cos theta. So DC cos theta, that is what we need. So if we have the vector CD and unit vector along AB, we just need to find the dot product to find this line segment C dash D dash. So we'll be using that throughout the questions. So just understand this concept. Why dot product of A and a unit vector along B will give the projection of this line segment on this line. So I hope this picture is clear. If you have any doubt, do comment. So this is the concept of projection of a line segment on a given line. Remember, these two lines can be, line segment and line can be on different planes, can be on same planes. It doesn't matter. So if we do like this, we'll get the line segment C dash D dash. So projection of a segment on a line on another line. Next, direction cosines of a line joining 2 points. So we have 2 points P x1 y1 z1 and Q x2 y2 z2. The direction cosines of this line joining these 2 points, let it be LMN, then L equal to x2 minus x1 by PQ, and M equal to y2 minus y1 by PQ, and N is equal to z2 minus z1 by PQ, where PQ is the distance between these 2 points, which can be found out using root of x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. So this is how you find direction cosines of a line segment joining these 2 points. So next, projection of the line joining 2 points. So we already discussed how we can find the projection in the previous section. So we have 2 points P and Q. We can form a line segment joining these 2 points, and we have to find the projection of that line segment on another line whose direction cosines are LMN. So we already discussed in the previous section that we just need to find a unit vector along that line AB, and if we have this vector also, we just need to find the dot product. We just need to take the dot product to get this DC cos theta, which is nothing but C dash D dash, that projection of that line segment on the line. So we will be using that here. So we have that vector here PQ, which is x2 minus x1i plus y2 minus y1j plus z2 minus z1k, and unit vector along the line whose direction cosines are LMN is nothing but Li plus mj plus nk. We discussed this concept while discussing what direction cosines are. Li plus mj plus nk is unit vector along the line whose direction cosines are LMN. So we have both. Now we just need to take the dot product to get the desired projection. So dot product, taking dot product of these two, we will get L into x2 minus x1 plus m into y2 minus y1 plus n into z2 minus z1 as the projection of required projection. So projection of the line joining 2 points and on another line LMN is given by this. Next is angle between two lines whose direction cosines are L1 m1 n1 and L2 m2 n2 respectively. So cos theta is given by L1 L2 plus m1 m2 plus n1 n2. I told you earlier that a unit vector along a line whose direction cosines are L1, M1, N1 are nothing but L1I plus M1J plus N1K. Similarly, unit vector along a line with direction cosine L2, M2, N2 are L2I plus M2K plus N2K. So cos theta between these two can be given by taking dot product of these two vectors. Taking dot product of these two vectors gives L1 L2 plus M1 M2 plus N1 N2. Since this is unit vector, so I just A dot B is nothing but mod A to mod B cos theta. So if you take dot product, and since this is unit vector, mod A and mod B becomes 1 and it gives cos theta. So cos theta is nothing but L1 L2 plus M1 M2 plus N1 N2. Similarly, if we are given direction ratios instead, A1 B1 C1 and A2 B2 C2, the equation becomes A1 A2 plus B1 B2 plus C1 C2 by root of A1 square plus B1 square plus C1 square into root of A2 square plus B2 square plus C2 square. So if you earlier I just discussed how we can convert direction ratios into direction cosines. So using this concept, and this cos theta is given by this formula. In combining those two concepts, we will get this formula. And next is finding sin theta and tan theta of two lines with direction cosines L1 M1 and L2 M2 N2. So sin square theta is 1 minus cos square theta, and which gives 1 minus L1 L2 plus M1 M2 plus N1 N2 the whole square. So now here 1, instead of 1 we are going to write L1 square plus M1 square plus N1 square into L2 square plus M2 square plus N2 square. These two are individually 1. L1 square plus M1 square plus N1 square is equal to 1, and L2 square plus M2 square plus N2 square is equal to 1. So we can replace 1 with this. So we are doing that to use the identity. This is a very famous identity. If we have this, we can convert this into this. So minus L1, if from this formula we can write this M1 N2 minus M2 N1 the whole square plus N1 L2 minus N2 L1 the whole square plus L1 M2 minus L2 M1. Sorry, here there is a whole square. So simply this can be written in this manner. Sin theta is nothing but root of, since it was sin square theta, here root of sigma M1 N2 minus M2 N1 the whole square. So just to if you have difficulty in remembering this formula, just if you write L1 M1 N1 L2 M2 N2, this can be found out like this: M1 N2 minus M2 N1. Similarly, next one will be N1 L2 minus L1 N2, and the next one will be L1 M2 minus L2 M1. So in this manner you can remember this formula. So sin theta is nothing but root of sigma M1 N2 minus M2 N1 the whole square. Now to find the tan theta, we just need to divide sin theta by cos theta, and we get this formula. Okay, so that is tan theta, sin theta, so cos theta, sin theta, and we are going to use this concept to find condition for perpendicularity and condition for parallelism. So cos theta, when two lines are perpendicular, we know that theta is 90 degree. So sorry, I have written it wrong here. It's theta is 90 degree, and that implies cos theta is equal to 0. And here it is sin theta, not sin theta, theta equal to 0 degree, or sin theta is equal to 0. Okay, so since theta is in 90 degree and cos theta is equal to 0, we can write L1 L2 plus M1 M2 plus N1 N2 equal to 0, and we can use this formula whenever the two lines are perpendicular. And condition for parallelism is theta is equal to 0 degree. The angle between the two lines will be 0 degree, and sin theta will be 0 then. So our formula, if we see in our formula, without going into this formula itself, if two lines are parallel, we can say that the direction cosines of these two lines are same, or L1 will be equal to L2, or M1 will be equal to M2, or N1 equal to N2. If two conditions. So how we can derive this is like this manner. We know that sin theta is equal to 0, and we know the equation for sin theta, and for this equation to be 0, m1 n2, and each term is a positive term, it's a square, right? So each term has to be 0, and for each term to be 0, m1 n2 has to be equal to m2 n1, and n1 l2 has to be equal to n2 l1, and l1 m2 has to be equal to l2 m1. So from this we can write L1 by L2 here, L1 by L2 equal to N1 by N2, which is equal to N1 by N2. From here we can write M1 by N2. So L1 by L2 equal to M1 by M2 equal to N1 by N2. So which is equal to root of L1 square plus M1 square plus N1 square by L2 square plus M2 square plus N2 square. Using the identity, this is a property of fractions or ratios, so which is nothing but 1. So we can get L1 equal to L2, and M1 equal to M2, and N1 equal to N2. So we don't have to go through all this. Whenever there is two parallel lines, if we know what direction cosines are, we will the angle each line makes with the positive x-axis, y-axis, and z-axis will be same. So cos alpha 1 cos alpha 1 will be equal to cos alpha 2, and we can say that L1 equal to L2. So from the definition of direction cosine itself, we can see that the direction cosines of two lines parallel will be same. So we can use that concept in the questions. So these are the basic concepts that we need to discuss before going to the questions. So I'll just go through them once more. Okay. So we have discussed this much. So we will be using all these concepts and formulas in solving the problems. We will start from the next video onwards. We will be doing problems from the plane, and after the plane we will take up other sections. So in case if you have any doubt in these concepts, do comment under the video, and thanks for watching the video.